Hello dear friends and welcome to another electronics project. So today we're going to build a charge pump LED driver. So just as some of the project specifications, so the circuit shall be able to drive 8 LEDs. All LEDs shall have the same current value. So all the same current shall flow through all the LEDs. This is used mainly to help produce the same kind of luminosity from the LED. The circuit shall be supplied by a 9-volt battery, so it's going to be a small circuit, and the circuit shall not use inductors. So we are going to use a charge pump to get the high voltage that we are going to drive then the LEDs. So going back to the architecture, so the supply has to be a 9-volt battery, and also I recommend a connector for the battery. And then this supply will go into the charge pump. So the charge pump works the following way. The 9 volts here, which are at supply, will charge the C1 capacitor through the D1 resistor when this PVM is low. And same in the initial state, everything will be discharged, but they will charge this C1 capacitor here. When this PVM goes high, goes to 9 volts, this means that this diode will not conduct because you will have 9 volts on this side and 9 volts on this side. So what would happen is if we do a Kirchhoff here, we will get that the 9 volts here plus how much you have stored on this capacitor, which is about 8 volts, then will be driven through this D2 diode to charge C2. So you can observe here that this is a single stage charge pump, which then is multiplied by 3. So this capacitor charges C2. Then in the next low value of the PVM, C2 will charge C3. And then when the PVM goes high, C3 will charge C4. And then when the PVM goes low, C4 will charge C5, and last step, C5 will charge C6 when the PVM goes high. Now, in order to make the circuit simple, we will need a integrated circuit that will provide us the PVM. And in order to separate the impedance from this 555 circuit here, I will use a push-pull driver that will get here a PVM signal from the 555 circuit, and this will drive the output, which will be this PVM high value here and PVM low value here. Okay, so when this is going to be high, this will connect the supply to the output, and then when this is going to be low, it will drive the output to ground through this PNP transistor. Okay, going a bit more in depth regarding the 555 integrated circuit, there are a lot of online tutorials about how to design a 555. You can find some. So yeah, let's search 555 astable calculator. There are multiple calculators. I recommend the one from DigiKey. So here you can calculate the exact value that you want. So for example, in our case, we will use a about 70 kilohertz PVM signal, very close to 50% PVM. So this means that here let's place for R1, let's put a 1 kilo ohm. For R2 we can put like 10 kilo ohms, and for the capacitor let us put um, 0.5 nanofarads. So for this, we will get a frequency of 137 um, um, 137 kilohertz. This is quite high, so let's put here 1 nanofarad, and then we have almost 70 kilohertz frequency here. Okay. The next step for the circuit is that we try to simulate the circuit in LT Spice and see how the circuit functions, and most likely see what the output here looks like after we start the 555 IC and see the PVM values. Okay. Okay, so I have opened LT Spice. Let's create a new schematic. And first, let's place the power supply. If you press on this button here, you will get all the component libraries, and here you can select from multiple components. Let's first put the power supply. So we will need the power supply. That would be a 9-volt DC power supply. And for a series resistance, let's put a 50 milliohm internal resistor here. Okay, and let's just connect this to ground and connect this here. Great. So we have the first step. Let's first create the charge pump. So this means that we're going to need, let's take a diode, and we are going to rotate this diode. Let me rotate it a bit so that it's facing the correct way. Okay, and now what we have to do is put the number of stages that we need. So first of all, let's create one stage. So a diode. Let me copy with Control C. You can copy a component. For the diode, I have when you click the diode here, when you right click it, you get pick new diode, and let's select a real diode here. So what we are looking for, if you click here, the current through the diode, there are multiple diodes that you can choose from, and you can see here what would be the current through this diode. So this is 75 amps. This is much more than we need. We're looking for about a 30 milliamps diode here, because we will not be pushing that much out of this component. So I'm looking here for a 30 milliamp one. Maybe would be better that I go through the component library. Let's see if I can find it. So it's 1N4148. It's not this one. Let's go back here. Go up 1N4148. So when you click the part number here, you get an alphabetic numbering for it, and you'll easily find 1N4148. Okay, and let's do the same here. So right click, pick new diode, 1N4148, and now we have placed the diodes. The next step is to add the capacitors here. So for the capacitors, we're going to use a 1 microfarad capacitor here for each stage except the last stage, where we are going to use a bit larger capacitors, where we're going to take a 10 microfarad capacitor here. Okay, so next what we have to do is copy this basic circuit. In order to create one charge pump, we will need 2 capacitors and 3 diodes. So let's copy the capacitor and the diode, and now we have one charge pump state. Okay, so this means that we have to multiply this stage by 3. So then I'm going to copy the capacitor, diode, capacitor, diode. Now we have two stages and we need another two stages. So capacitor, diode, and capacitor. So this one will push into the second one, this one will push into the third one, this one will push into the last one. Okay, and here this means that this we have to put at 10 microfarads, so that this is the output capacitance, and this would have the highest capacitance here. Okay, so let's just connect everything. So to connect everything, please use the wire here, and let's connect every component here on the top side first, and then we will choose for the bottom side the PVM. Okay, so we are just connecting everything. Great. One last step that we have to do is to add a load, and then we can move to the other side. So we said we want to supply 8 LEDs, and they have to be all the LEDs have to all LEDs shall have the same current value. So this means that we have to put them in series. So let's go back to LT Spice, go here for components, LED, and we have to put a series of 8 LEDs here. So 4 already. Okay, scroll in, scroll out for zooming. 5, 6, 7, 8, and now let's place the ground. One thing, so let's select an LED here. So here would be a type for the LED. Here you will find different components. So would be LED type. So let's search for, we have Zener, we have silicon, Schottky, diodes, and fast recovery diodes, but no LED. This is weird a bit. Okay, let me check again if there are any silicon, Schottky, Zener. Okay, so there is a type LED. Okay, so we have found them. Let's take a diode that has like 30 milli milliamps here. So let's take this one, and then let's put the same one. Maybe I can do this faster if I delete the diodes and then just copy the last one. So for deleting, press delete button on your keyboard, and to copy, just Control C. So 1, 2, 3, 4, 5, 6, 7, 8. Great. So now we have all 8 LEDs, and then let's just connect everything and also connect it to ground. Okay, all components are connected to ground. Great. The last step is to add the PVM. So first, let's separate the charging capacitor to the ballast capacitor, or the capacitor that we are charging and we're pushing capacitance into. So I'm just going to add grounds here. So I see this one is charging this one is charging this one is charging this one. Great. Okay, let me just move this a bit low. Okay, and let's add the wires for the capacitors. These are the ballast capacitors, the one that we are charging. And let's first do a test run without a 555 circuit. So let's put a voltage source similar to the one we placed previously, but we are going to connect it. Okay, let me put the wire correctly here. Okay, now let's go to the advanced button of the power supply, and let's select the pulse power supply. So we can put a initial value of 5, a on value of 9 volts, no delay. For the rise time, we can put like 0.1 microseconds, 0.1 microseconds. Now we have to calculate for an estimated frequency of 70 kilo. Okay, this would mean in milliseconds would be about 14.2 microseconds, if I'm doing this correctly. Okay, so this means that here we are going to have 7 microseconds and the period would be 14 microseconds. Okay, I'm not going to set the number of cycles because this is going to run continuously. And let's connect this power supply that at the moment it simulates the behavior of the 555. Let's connect this to the capacitors. Okay, second capacitor and third capacitor. Great. Last thing to do before we run the simulation is click the simulate and edit simulation command. And here we can put the stop time. Let's put a 25 millisecond stop time just to see how things are working. Okay. And let's run the simulation. And it is running and the output looks like this. Okay, we've went from 9 volts to 30 volts here on the output, and the current through the diodes, through the LEDs, of course LEDs are diodes, it's about 25 milliamps. So this is great. We have a working functional charge pump that is driving these LEDs, these LEDs, and at a constant current through all the LEDs, so they will all have the same brightness level. This is great. Next step. So for this for the next step, we are going to need a 555 IC. So let us first delete the power supply here. Okay. And now we're going to need a 555 NE 555 oscillator here. Okay. So first of all, we need to connect the the supply according to the schematic. So if you go here, we have the reset and the supply are connected together. So let's go back to the schematic and connect the reset and supply is connected together. Next step, we have the discharge with a R1 resistor of 1 kilo to the supply, and between the discharge and the threshold we have a 10 kilo ohm resistor. So then we have to place here a resistor and another resistor here. Here we are going to put like 1 kilo ohm. This is R1 between the discharge value and the supply. So let me connect this before we forget here. Okay, and the second resistor is a 10 kilo ohm resistor. So let's place here 10 kilo ohm. Great, and this will go to according to the schematic. So the second one, 6 and 2, is connected. We'll go to the C1 capacitor, which is 1 nanofarad. So going back to the schematic, 6 and 2. So these two are connected. 6 and 2. And these are also connected here to the capacitor that would the 1 nanofarad capacitor. So this is 1 nanofarad capacitor that will go to ground. And let me add ground here. Okay. Now one last step before we can start. We need to add the capacitor here to the CV pin, and let us put a like a 200 nano farad capacitor here, just that we are safe from capacitance point of view. Okay, and last steps would be to connect the supply to the same supply of the power supply here. Okay, and the ground to be connected to the voltage reference here. Okay, and ground is connected here. Great. Let us just pull a line over here so that we can measure, and let us run again. Okay, we are measuring the current now. Let me delete this trace. So now let us see the PWM signal. So we can see that we have a PWM signal here. It's quite beautiful PWM signal, no issues here. So the value, so the 555 works quite well. Next step for us is to separate the 555 and the charge pump. Okay, so let me delete this here. And what we are going to do is create the push-pull structure that we've been discussing previously. So we're going to put a NPN transistor here. Okay, let me mirror this transistor. Okay, and also a PNP transistor. For this we have to both mirror it and rotate it. Yes, no, I still have to mirror it. Okay, great. And the output from the 555 will go as a driving voltage level to this push-pull structure. That will then in turn, so this output here will be our PWM signal for the charge pump. Okay, let us see this here. Okay, let us also delete the small trace. And the push-pull has to go between two levels. In our case is the supply and ground, so it will push the value from the supply to the ground, and the value from the so here will pull down to ground, and here will push up to the supply. That is why it's called a push-pull circuit. So let's run it and see. And now we're seeing the PWM values for the 555. Okay, and we're just doing till 25 milliseconds. Great. Now let's see the values here. So the values are going up to 26 volts, and let's go to the current. So this is pushing to the current here. Oh, this is also voltage, and the current going through this, it's about 7 and 7.5 milliamps that it's pushing through the LEDs. Okay, just one more recap on the circuit. So the charge pump has the role of pushing the capacitance or this switching capacitance to a reference capacitance here. So this will, in the first stage, when this is low at ground, this will have, so we can see now also. So in the first stage, you see that the value of the voltage rises as the capacitor is charged and discharged, and you can see that it's pushing above the 9 volts, is pushing a PVM value here. So then this is charging the capacitor, and then on the other side, on the ballast capacitor here, here it's just adding. So it's taking this value here and creating an average for the value there. So it's looking like this. Now this looks like a switching, like a sawtooth a diagram, but let me, maybe I can do it a fit, or I can do a zoom out. So the values are millivolts here. It's quite small value. And then the second stage would be here. So you can see that the first stage pushes to 14.5 volts, second stage pushes already to 20.4, and the last stage, which has also the biggest capacitor, pushes to 26 volts. So the target for this circuit is to push this capacitance over a voltage level, which is in our case is 9 volts. So we're just pushing charge over the voltage that we are running. Okay. Second circuit that we're discussing here is a astable circuit here for a 555 integrated circuit. So this circuit works as the following. So it charges this capacitor here, and then this charges through R1 plus R2, and then it discharges through R2, and then it constantly goes between charging and discharging this capacitor here. And the output from this, so the calculation, the actual calculation, you can find it in the calculator. It's quite simple to use as a calculator. This will generate almost any type of PVM you may need, and it's quite versatile circuit to do a PVM output, and it's quite simple. And the push-pull has the main target of supplying the or shorting the supply. So it's either pushing 9 volts to the PVM here. So it goes the following. Here you have 9 volts. When this is high here, this will conduct, and it's pushing 9 volts over here. Here you have like 0.3 volts voltage drop between the collector and the emitter, and the PNP is pulling down, so it's taking the value from here and driving it to ground so that you can charge the capacitor. Okay, so these are three simple circuits: the charge pump, the 555 astable, and the push-pull driver. Okay, so this means that we have created a simulation. The final step that I would like to go through is to do a TinkerCad simulation, which is a really good software tool just um, to be able to simulate a circuit. So let's create first a circuit. Here in TinkerCad, we already have a battery, a 9-volt battery here. You can see the negative and the positive terminals. Let us take all the components from the library, and let us place also a breadboard, because we're going to need this board to supply everything from here. Let me rotate this so that I can connect. So we can see here for the breadboard, all these pins are connected on the top side and on the plus and the minus, and each line here is connected together. So let's connect the supply. So this is the plus line, and this is the negative line. So negative I'm going to connect below. Okay. And just for symmetry, on the other end, I'm going to connect the plus from here and the negative from here. So we have the 9 volts supplied here. Great. Next step is to add the diodes. So let me rotate this diode here. So we are just going to place the diode, then a capacitor, then another diode. Let me see here. It's quite okay. Now it's much better. Then another capacitor here on the output, then another diode. So here we have one stage. Now we have, so let me just connect. I think I can connect all the diodes together. Okay, maybe I can do a control C. Yeah, I can do a control C, control V, control C, control V, control C, control V. Let us add, so these are the first pair of capacitors, second pair of capacitors, control C, control V, third pair, and fourth pair. So this one is charging, the first one is charging the second one, third one is charging the fourth one, fifth one is charging the sixth one. Okay, great. So this means that we only have, let me delete these two because these are in addition. Let me just add the connections. So the first one goes from the supply. First one is connected to the PVM here. So in order to simulate, we will need to use a 555 integrated circuit. So we can place the 555 here. Okay, and let's create the circuit. So going back to the schematic of the 555, so pin 8 and pin 4 are on reset. So this is pin 8 and pin 4, so this means that these two are connected. So let me go on the other side, pin 4 and pin 8. Okay, are connected. The discharge is connected by R1 to the supply. So these are also going to the supply. Okay, discharge is going by resistor, 1 kilo resistor to the discharge is going to the let me see if I can place it here. I'm going to place it like this. So discharge is going to the supply. The between the discharge and the threshold, we need a 1 kilo ohm. The other one is a 10 kilo ohm resistor. And what we need is the capacitor to switch. So the terminal of the capacitor goes to ground. This is a 10 kilo ohm resistor, and the connection between these two goes to 6 and 2. So this means that we have 1, 2, 3, 4, 5, 6, 6, and 2. So here is 2. Let me connect everything together, and 6. Okay. Okay, so Discharge power is connected. Ground needs to be also connected here. So this is ground. We need also the control voltage here to connect with a big capacitor here. So let me check how big I use this. This is a 200 nano capacitor. So going back from this point, I'm going to need from this point a 200 nano capacitor, 200 nano, and here we have a 1 nanofarad capacitor. Okay, and this is kind of looking good. The reset is connected to the supply. Here I have the output. Here we have the trigger, which is connected here. Okay, and the ground here. Super. So this is great. Now we have the output here. So let's in the first step, let's see how we can add the FET transistors or the simple it's bipolar transistors. So I'm going to add two transistors, the base of both of the transistors. So this is an NPN and a PNP transistor. So the collector from the NPN is going to the supply. The bases go together. Okay, I need to connect this to here. Okay, the emitter from the NPN goes to the emitter of the PNP, and I think I connected this to ground. I need to connect this to supply, and the collector from the PNP goes to ground. Great. Now all we have to do is take this pin here. Let me connect this. We need to connect this pin here to the output from the 555. So I'm going to take this here, connect it to the maybe not that connection. I'm going to take a pin from here, connect it here, and then from the output here. So we've put the output of the 555 in the bases of the NPN and PNP transistors. And now we need to connect the outputs. So these are going to go into the driving circuit for these LEDs. So let me take a connection from here. And this will go all the way here for the LEDs. Okay, great. So now let me also add the capacitance. So here we have 1 micro. Let me put a 1 microfarad. Here we have another 1 microfarad. And here we have another 1 microfarad, another 1 microfarad. Last 1 microfarad and a 10 microfarad capacitor. Okay, so we've connected the output from the transistors to the first capacitor. We need to connect this also to the third capacitor because they are going in line. So let me delete this, and I'm going to take this from the third one. I think I have to do it through here. Okay, and then we need also the fourth one. I'm going to push this here and drive it here. Okay, and the other capacitors are going to ground, all of them. So this is just a simple connection to ground here. Okay, Okay, and this is going to ground. Okay, let's do a first run here to see how things are working. So I'm going to connect the negative to the ground and the positive really ugly to the output here. And let's run the simulation. So here we can see it's going up, it's going up. The capacitance here is going up, 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 up. And let's see how far this goes. So this is running a bit slower than the LT Spice simulation. So don't worry about that. It happens. So while the capacitance is charging, you can see that the values going up and up here. And we should be stopping at about 20 volts here. So we are already 17, 19, 20 volts, okay, 21 volts. So we are stopping at 21 volts in the charge pump. So this is really good. It's another simulation software where we can test our design. So last step is to connect the LEDs. So in order to not add to the already complicated breadboard, I'm just going to put another one just for good measure, where I'm going to just put the LEDs. So I'm going to put an LED here. I really like blue LEDs, so then I will put this. So we need to add, let me rotate this. So, or maybe we can start from this side. It doesn't actually matter because we need anode, cathode, and I'm going to multiply the circuit uh, 8 times. So I'm going to copy this here, copy this here. Okay, so we have 1, 2, 3, 4, 5, 6, 7, and 8. Then I'm going to connect the cathode to the anode, cathode to anode, cathode to anode for all components. Okay, and then I'm going to connect a negative line here, just that I have a reference here for this, and I'm going to connect it here to the ground, and then the supply will be coming out of this diode here. Exactly, and now let's see how things are looking. So we start the simulation. The charge pump is working. You can see the LEDs are starting a bit to change color, and they're charging and they're charging, and the charge pump is working because it has to push capacitance from one capacitor to the other, to the other, to the other. So it will gradually increase the capacitance is pushing. You can see now it exploded. So already here we get an error which is saying current through LED is 43 milliamps, recommended maximum is 20 milliamps. So we can solve this, it's no problem. So let us remove this, and we can add a parallel resistor, a series resistor, sorry, not a parallel one, a series resistor here. And let's put this for, let me see how big this one is. Oh, let's put like 100 ohm resistor, and let's do the same connections here. So I'm going to take this here and place it on the output. Please make sure that the connections are made correctly in TinkerCad so that the circuit functions. And let's start again. So we're just charging slowly, slowly charging the capacitors, and at some point it will trigger because the capacitance has already moved from one side to another, and then we're just pushing quite quite high current here. So let's see how things are looking. 1.1 volt, and now things are going to start moving up from voltage point of view. can see, okay, exactly. So, oh, still, there's still the error. So let me see this again. So it's still the error here. So current, how much is it? I can also increase the resistor, so we can increase this to 200 milliohm, 200 ohms here, so it's no problem. It always takes a bit of tinkering just to get the correct setting for the values. So yeah, expect to always change something a bit. um, but yeah, basically today, we have discussed a charge pump, a three-stage charge pump circuit, a 555 linear astable, and a push-pull driving circuit, and of course a series of LEDs that are supplied at quite high voltage here. And now we can see that the error is no longer in question. All the LEDs are switching at the correct frequency. And I think with this, we conclude the project. Okay, so this was our initial requirements: to have it simple, to have it not use any inductors, and to use a 9-volt battery here to supply all the LEDs at the constant current. This is the circuit. So thank you everybody for watching. If there is anything that you would like me to go more in depth, please yeah, feel free to comment, write me, and if you like my content, please subscribe. Wish everybody a great day.